Check, check, check. Good to go? Okay, everyone, welcome. I don't know how I got so lucky to get the first slot after lunch. So, if I see anybody sleeping, I'll say, hey, wake up. And, if that's you, you can wake up or stay asleep. I don't care, one way or the other. All right. This talk is going to be, planning an OpenStack cloud for production. This is geared towards folks who may have, they have OpenStack running on their laptop, or maybe have a POC environment, or maybe have a POC and development environment, and are thinking about taking OpenStack into production. There are a lot of things that we need to think about before going into production, and just slamming PackStack or DevStack into production is a sure way to limit your career opportunities in the future. So let's all not do that. But there's a lot of things to think about. So, before we talk about a plan, you got to think about, what is my mission with this cloud? Did you just build a cloud because you thought it would be cool, and did no one ask you to build it? If that's the case, you're going to have a lot of challenges. OpenStack clouds are not like baseball fields. You can't just build them and people will come. The only one who'll come is your finance guy and want to know, what are you using all this really expensive hardware for? And you can show him your cloud all you want, but I doubt he's going to be impressed with how cool your cloud is. So we got to talk about, what is the mission of your cloud? Are you doing this to save money, increase agility, increase performance, stem faster innovation? That's really what we need to decide before we start planning a cloud is, what is my mission? I used to be a pilot, and a private pilot, and a lot of guys wanted to buy planes. And they would start looking at small planes, and then they would get up to bigger planes, and then twin engine planes. And a very seasoned pilot one time said to one of these pilots that were looking at a multi-engine plane, what is your mission? What do you want to do? The guy says, I love to fly. He said, well, why are you buying a plane that goes so fast? If you love to fly, you want to buy a small plane and get there slow. And it's kind of hard to operate, and you're actually flying it. What does your company want to do with this cloud? Do you have an internal champion? Do they have budget? It's enough, it's one thing for your CTO or CIO or unit CIO or unit chief to say, hey, I'm interested in this OpenStack stuff, and you go out and you build a dev cloud for them, and then you go, hey, I want to get some new hardware, I want to go with a distribution, and oh, we don't have any money for that. We thought you could just do it, right? I don't know how many times I've heard that. I've gone into customers and, oh, can't we just download it and put it in production ourselves? Yes, you can, but you have to have the resources to do that, and you have to have the planning to do that, and you're going to have some sort of budget. So really, before you go into OpenStack, yes, it's free open source software, but it's not, the people working on it aren't free, the support for it isn't free, unless you're doing your own self-support, and some of the tooling around it isn't free. So you have to have a budget and have an idea. How does OpenStack fit with your corporate culture? Are you a bank that runs mainframes and mid-range, and VMs are kind of new to you, right? I don't think OpenStack's really going to fit that culture with open APIs and being part of DevOps and Agile, right? That's culture shock. That's enough to give people heart attacks. And you don't want to give the mainframers heart attacks because they're old already. Do you have talent in-house to plan, deploy, and operate OpenStack? Just like I was talking about before. Are you going on, are you Rambo? Are you like OpenStack Rambo? Like, are you going on this mission by yourself? You're going to engineer it, build it, administer it, operate it, deal with customers. If you are, I have a job for you if you're looking to do that, if you're that good. But typically it takes a team. Not a huge team, but a team of dedicated people who are dedicated to this. They can't work part-time on OpenStack like 2 hours a week. Okay, it's just not going to work. Are you considering a distribution? A managed OpenStack distribution, or are you doing it yourself? As I talked about before, each one of those has budget, staffing, time, approval, and lots of different constraints. And what will run on this cloud? Will be for VMs? Will it be for containers? Will it be for provisioning bare metal? A little bit of both. How many hypervisors will it have? These are types of things that you want to think about before you even start planning. So here's your action plan. Okay, this is not all inclusive, all comprehensive, but this is a good chunk of what you'll need to do. You define your use cases that your enterprise needs for your first production cloud. What are your use cases? What types of applications are coming over? Do I have web applications? Is this a database cloud? Is this a cloud that hosts some sort of third-party COTS software? Is this a cloud that's going to be used primarily as a data collection cloud for big data or data processing or Hadoop? What are all the different use cases? Let me give you a little piece of advice. Don't ask your whole company to bring their use cases and then take them all, accept them all. You're going to have to vet them. And if your first use case is like multi-cluster Kubernetes with various types of containers that need to do all sorts of grid network solutions, I would tell them to hold on for like a year, because if you're going to get into something that complex as your first use case, you're going to be a little frustrated. So let's pick some use cases that are doable. And again, maybe you do have, Envoy experience, or Courier experience, but a lot of people, don't. So think about something that you can go into fairly easily and be successful. Collect the capacity data of the use cases you want to bring. It's not just enough to say, what's your app do? And what kind of projects will I need to incorporate in this cloud? You also have to say, how much is coming? Because I've seen the mistake of people saying, I want to build my first production cloud, and here's the application I want to bring on. It's a simple enough application. And then when the people come, they come with like 9,600 terabytes of storage needs, and they need like 2,600 compute nodes, all sorts of crazy IPv6 networking, load balancer as a service, lunch as a service. I mean, everything. They want everything as a service, and it requires you to lay down a budget of millions and millions of dollars, and you start off with, but this was a simple use case. But you never ask them about their capacity. So collect your capacity data of all the use cases that you want to bring so you can make intelligent choices about what storage backends, network backends, compute backends you want to bring in. Determine the size of your cloud. And I'm talking about your initial cloud, not your cloud from 6 months from now, or 8 months from now, or 9 months from now, or a year from now. Because why do we like clouds? Clouds are elastic. So the cloud you start off with should not be the cloud that you end with. It should have a certain capacity plus a variable coefficient of elasticity. Yeah, that's fancy words. It should go like this, okay? And it should plan for a reasonable amount of time before you need to expand it. Now, all of those things, your elasticity coefficient and your reasonable amount of capacity is all directly related to the size of whoever's paying for this, wallet, right? So again, let's not spend all the money right away unless your budget's ending and you need to spend the money by the end of the year. Then feel free to call me because I have some ways you can spend some money. Research the OpenStack projects you'll need to satisfy your requirements. So once you get these use cases, what projects satisfy those? Do you need load balancer as a service? Well, what's the project that's tied to that? Well, that's Octavia. Well, great. What are the features that Octavia has? Do they meet the same features as your current physical F5s? Did you know F5 has a VNF, or virtual network function, that can be run as a load balancer in the cloud? Well, you do now. So maybe that's your solution. So before just default saying, I'm going to go with this project because it says load balancer, you really need to research what it is that you need. All the different layer 2 services, layer 3 services, in the case of the networks. Same with storage, same with object storage. So also, when you go back, you want to create your hardware architecture from business and technical objectives. So your business objectives is, I want this application to run like it does on my traditional, my legacy hardware and my legacy virtualized environment. Okay, how many IOPS does it need? Oh, it needs, a bajillion. I need 2 million IOPS for one VM, right? That's a technical requirement. Not realistic. That's what any developer will tell you, is that he needs all the storage in the world and all the bandwidth in the world and all the speed in the world. But you need to get real technical requirements, and whether that means putting in probes and finding out what these requirements are for these apps, or putting virtual taps or physical taps in the network and finding out what bandwidth is coming out. Looking at your storage, getting your current storage appliances, looking at if you're coming from VMware, bring up COPS or VCOPS, bring up any vSAN statistics. See if they're telling you the truth. Build your technical requirements. And then you have business requirements, right? I need it to authenticate here. I need it to supply me with self-service for my users. I need it to have broad network access. I need it to do metering and show me what these people are using, because I'm charging these business units, right? If I'm dumping a bunch of money in, I'm buying all this hardware for them, there's no free lunch. You were buying your hardware when you were buying physical machines. Why wouldn't you pay for my metered usage, right? These can come down from the top. Believe it or not, these trickle down into your OpenStack architecture, right? What are you going to need to do metered billing? What projects will you need? What will you need to support those projects? Create your deployment and execution plans. So deployment and execution. Deployment is, here's how I'm going to put it out. Here's the resources I need. Here's the resources I'm going to use. Here are the people, the amount of people I'm going to need. Here are the places I'm going to put it. Here's the cooling and power requirements I need in a data center. All of these different things are part of a deployment. A lot of people forget about this. They forget, what if I put out 100 nodes of OpenStack? Well, those are 100 Dell, 360s or HP, 740s. Whatever they are, you're still putting them in a data center. They still need the capacity planning with your physical plant that any other physical install would have. Here's one that everybody forgets. Well, I wouldn't say everyone. A lot of people forget. Run unit tests on all your components. Test capacity and high availability. So people do this. They say, I've gone through my deployment plan and my execution plans, and I know what I'm putting out there, who's putting it out there, what the timeline is, who's responsible for what, and I'm going to put it out there. And they put it out there, and it gets out there, and they say, okay, what now? All right, let's get people on it. And they start onboarding people. And then some executive will come by and say, did you test it? Test what? What do you mean test it? Did you test it? Well, yeah, it's running, and I can build a VM. Look, boop, boop. Okay, that's not testing it. That's like getting in a car and saying, yep, I can start it up. Yeah, oh, look, it goes into gear. I drove it 4 feet. Yeah, you need to buy this car, man. This thing runs like a charm. No one would do that. You want to take it for a test drive. Some people, like friends of mine, take test drives a little differently. And that's how you should test drive your OpenStack, right? You test drive a Jeep. What, you put it on the road? No, you find a dirt road somewhere. Hey, this is what I bought a Jeep for. And then you get a deer trail somewhere. And then there's a rock face. And you take it up the rock face. And then you call the state police because you're stuck. But it only happened once. So, all right, but I'm not saying to do that to test, when you're test drive. But I'm saying with your OpenStack cloud, you need to seriously test all components, everything. Every project you put in, not only do you test it for functionality, do synthetic tests against it, but you need to do capacity testing against it. There's a project out there called Rally. And with Rally, you can test every component. You can test networking performance. You can test provisioning performance. You can test performance of pretty much everything. And I love doing this to clouds, is you can put the hammer down. So build me 10,000 VMs on my 2-processor NUC, right? And I want them built immediately. So Rally will do it for you. Bam, 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 bam. right around, say, 75, the thing starts to seriously slow down. At 100, it pretty much is raising a white flag and then becomes unresponsive. And don't ask me how I know. So these are the types of things you need to do to your cloud before you put people on. People really don't appreciate if you're testing north-south networking by jamming a bunch of packets in there and restricting their bandwidth. I don't know why, they just don't like that. So we need to do that before, and then your high availability, right? Let's pull the rug out from underneath one of your controllers or one of your systems running control services. A lot of the distributions now run the control services as containers in a server. Shoot that server in the head. Pull the plug out, see what happens. Should all just fail over, should just work. You want to find that out before you put customers on. You want to find that out today, not tomorrow. And if it doesn't, then you need to figure out what you did wrong, why Kubernetes or Keep Alive D or whatever you're using to keep your HA services running, why it's not working. But it's a lot better to do that the day before than the day after. So how do we do this? What's a practical way of doing this? The design document. There really should be a document. And I know it's like, I'm not a technical writer, I don't do all this. Yeah, you got to do it. All right, you got to find someone to write it for you then. But you have to put these things together because your executives and your leaders are going to want to see them. Summary, just basically a detailed summary of the entire document. Write this one last, even though it's summary. You want to write all your findings, how this cloud's going to be built, how it's going to be tested, how it's going to be designed. Second part is the design review. It's the meat of the document. The requirements can be whatever format you want. A lot of people use user stories, right? I would like my cloud to be able to provision and deprovision 1,000 instances per day with no loss of performance. I would like my cloud to so-and-so, be on and on and on and on. Or you can just say, needs to be able to provision this, this, and this, right? You don't have to use user stories. It's kind of an agile thing. But you've got to put them down. You got to put all of the requirements down, and that way you can show that the requirements will be met with the architecture. Hardware architecture, the way I like to do it is I get down to the nitty-gritty. I get a bill of materials, how I'm going to build this thing, and I write down every component. Boom, 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 boom. I give pictures of the servers. I show where things are going to be plugged in. Here's the ports. And in some cases, when I'm separating my networks for OpenStack, when I have these isolated control networks, user plane networks, management networks, I show where those are actually going to be plugged into the servers. I also show where they're going to be plugged into patch panels. I do full network diagrams. Now, again, your mileage may vary. You may not be as anal as I am. But I like to deal with these things because the next person that, when I was building clouds myself for my own company, or the company I was working for, I knew that if I left or something, that somebody would appreciate that. Or when they fired me, the next guy could say, oh, that's what he did. That's why he got fired. So, they really should be very detailed. The next part should be your OpenStack architecture. And what I mean by OpenStack architecture is the projects that you're going to include, possibly any interactions you need, or even your OpenStack map. How many regions you're going to have, how many domains you're going to have, large picture down to the individual cells. If you're doing Nova cells, it's really how OpenStack's going to be laid out. And then your roadmap. So remember we talked about having one use case that you really wanted to push? Well, what about the next use cases? Well, I guarantee you're going to look at a certain number of use cases, and you've put off a certain number of use cases because maybe they've got projects listed with them that are in incubation, or maybe that are not part of your distribution that you're using, and you're waiting for your distribution's next release because they will be part of it. So on your roadmap, you should be indicating, we have this today, we'd like this tomorrow, and here's the functionality we're going to have tomorrow. That way, when the developers come whining to you that they want to do this and they want to do that, you can say, hey dude, it's on the roadmap. It's coming to you next summer, chill out. It's all good. I don't suggest you talk to them like that because they kind of feel like they're being pandered to. And don't get me wrong, I love developers. It's in some other room. So, the roadmap really is important. The deployment plan, again, we do a summary, and then the deployment. What will be deployed? What are you deploying? Everything. Tell me, everything you're deploying. Guess who else is going to look at this deployment plan if you do the right thing? The storage team, the network team, the security team, the team that manages the teams, the team that manage those teams, the bosses that manage those teams. Everybody's going to want to put their input in. And when I was doing an OpenStack cloud at a bank that rhymes with American Schmishmesh and has a Centurion logo, when I did it, I made the mistake of putting them all in one room and kind of informing them of this as a group. That was a very long, painful meeting. I remember the security or the network guys just repeating the word no over and over. No, no, no. What do you mean software-defined network? No, that's not happening. You're going to assign your own IPs? Yeah, right. You're funny. Is it April already? No, it's not. I'm not joking. So, this deployment is about everything that you're doing. And then your execution plan, like I said before, this says Bob or Bob's team or Fred's team. They will be setting up the NetApp filers or the NetApp storage grids or the NetApp whatever or the EMC VNX for my OpenStack. And they will be setting it up in this way. If you want to do a RACI chart, that's fine, responsibilities matrix, but it should call out everybody who's responsible for what. Otherwise, it's just going to be bad because they're going to think, oh, no, you were doing that, or I wasn't supposed to do that. Some things I've learned. And then day 2 operations. Everyone forgets about this when they do an OpenStack cloud. I swear everyone does. Maybe not for long, but for when they get this thing up, they never think about, okay, I've turned it on. Oops, I forgot to tell operations that this was running. And maybe, do my current tools work with this? And did I talk to operations about logging, monitoring, alerting? And do they know the concept of compute nodes and all the vernacular that we use and the control plane and the Cinder service? And you go into guys who've been running WebSphere on VMware, they're going to be like, what language are you talking about? I have no idea. I just see that's red. Is that bad? I don't know. What do I push to make it better? You need to include the operations team. So day 2 operations are also a concern when you're in the deployment plan. So when you're looking at your point of departure, and as I said before, why is there a need for change? And this is what we're going to be putting in our deployment plan, or our business plan. Is that, why is there the need to change? What are the expected outcomes? What are your KPIs? You're going to be putting this cloud in, right? Your leadership is going to be expecting something. Something quicker, something cheaper, something faster, something different, more tools, more agility. So what are your key performance indicators? What are they going to get for all this money that they're spending on the OpenStack cloud? You really need to know that and be able to measure it before you start putting a cloud into production. Examples here. Company XYZ is finding itself behind competitors in regard to innovation because it cannot deliver infrastructure to developers quickly. A lot of OpenStack was installed because of that, right? We have physical machines. We have VMware that may not be set up with any sort of self-provisioning. So you go into ServiceNow or some IT service catalog, and I need a VM of this size and this much memory and and this much vSAN on this network and this network. Go, and it goes to the printer of the VMware administrator, and he goes over to his printer and he takes it off the printer and he sticks it on the, one of those pins, like slaps it down around the, and he goes, and he has a big sign that says 10-day SLA. And then he goes back to playing Fortnite for a while, and he looks at the big stack and he goes, yeah, I can still make all of those in 10 days. I'm good, right? So not saying that this is everywhere this happens, but I've seen this happen. I've seen 10-day SLAs on VMs and swivel chair stuff like printer, guy, oh yeah, approved. Here, go install this. Oh yeah, okay, here. Hey, intern, go install this. It goes on and on, right? These people are going to be, so this is what's happening. So developers need infrastructure quickly so they can develop quickly to get to market quicker. XYZ company is finding itself in that situation. The current virtualization platform ABC Enterprises is running is non-directional and too expensive. Can anyone guess what they're running? Too expensive, non-directional. It's a virtualization platform. Anybody have a guess? Scream it out. Where is right? You got the end of it right. What was the first two letters? Yeah. All right. Anybody from VMware in here? I'm sorry I'm picking on you. Great virtualization platform. Not so much a cloud. So again, a lot of companies are moving in that direction. So expense, right? The licensing is expensive. El Dinero Bank has data that it needs to process quickly, but it cannot leave the data center. Scaling takes too long with traditional infrastructure, right? So Christmas time comes, bunch of card transactions are coming in. The fraud team's going nuts, right? Its Hadoop clusters are working overtime. Uh-oh, our 25% capacity we had left over from last Christmas just isn't cutting it. Okay, scale. Hi, HP, yeah, I need some new servers. Can you FedEx those to me? Yeah, quick. What, 4 weeks? Yeah, why? Oh, memory's backordered? Oh, yeah, I'm gonna need those in like 4 hours. Yeah, no, not possible? Okay, bye. We're in trouble. So El Dinero Bank is gonna move to something that he can have dynamic scaling, right? He doesn't have to worry about it. His teams can expand his Hadoop clusters and do big data quickly. Joe Telco wants to be able to scale in and out its network functions, right? Again, emergencies happen, things go on, unlimited plans get launched. You need to scale in and out. Can't do that with traditional infrastructure, dynamically anyway. And college university has genome sequencing, right? They struggle with setting up the infrastructure for big data, right? They want to push out big Hadoop clusters to do genome, but they also want to collapse them down very quickly. And they want to let the users do it themselves, and they want to meter it. Can't do that with any other platform. So these are the types of business reasons, business objectives that are important. I talked before about current state and taking list of capacity. On the right, that's a little bit of that. Solution principles. So you're going to have solution principles, specific principles that'll have to be adhered to regarding capabilities and requirements. Application deployment principles, via a single tool that uses an open API. So whether that tool is Terraform, Ansible, Helm, they're going to standardize. This company is going to standardize on a single tool. Maybe that single tool requires a different project. That's for you as an architect to figure out. What is the project within OpenStack that will support this type of application infrastructure as a service? Single region. We have a single region, authentication, authorization, and access from an integrated solution in the same region. Well, is that Keystone? Are you going to put an AD farm in that single region? You're going to push it off to LDAP? How about OpenID? How about Google? Maybe you want to do two-factor authentication. It's all possible within OpenStack, but you need to make the decisions up front because it is a solution principle. Configuration portability. Ability to have persistent storage mechanism to store configurations, config drives, or maybe configurations that you can store in some sort of object store. Well, if you don't engineer in object storage, you're going against your solution principles. And then, another one that was handed down, faster, more reliable IaaS. So you have those that are coming from developers and executives. Then you have technical principles and requirements. Scalability, the ability to support a certain number of compute nodes in 52 data centers, 52 independent clouds, all in the same domain possibly, maybe 5 or 10 different regions. If you didn't know this going in, if you didn't have these technical requirements, you could really not install your cloud correctly, not join it to the right domains, not have it in the right regions, not set up possibly disaster recovery properly. Network, the ability to support, private IPv4 tenant networks in a single cloud. Right? So what if your default mode was to set it up with setting up with VLANs, we're setting up with provider networks under Neutron. You think because that's what you're using VLANs in your company. Well, you've set up Neutron completely wrong now. You're not going to be able to do IPv4 inside of tenant networks and then give their own private IP addresses, unless you've set up floating IPs. I'm not going to read all of these. These are the types of things that you need to think about. So you need to get your business requirements, you need to get your solution principles, your technical principles and requirements, all in ahead of time. So putting it all together, we need to define the business challenges we're trying to solve and outcomes we're looking to achieve. We're doing these types of things. Under the bullets under there are what we will win. You record the technical objectives. You get them down. You get your leadership, you get your development, you get whoever's driving this cloud, your executive sponsorship to tell you what are these business and technical objectives. You get other engineers, your network engineers, your storage engineers. You say, well, if you're going to build a new cloud, it has to support this and this and this because that's what the apps need. Record any assumptions, capabilities, requirements of the platform. You need a single tier of storage that has greater than 2,000 IOPS of performance per instance. Let me tell you, Ceph, a lot of people want to put Ceph in, right? Ceph is great. I love it for distributed storage. But Ceph on spinning disks, you'll be lucky if you get 500 IOPS per VM out of it. Somebody says they need 2,000. Well, you said, but I went with Ceph. They'll say, but I don't care. But I need 2,000. So, there are ways around it, but you don't want to have to do that. You don't want to have to re-engineer your cloud after you've already engineered your cloud. Technical architecture and OpenStack architecture. It always goes back to the business and technical objectives. You create an MVP design. I don't know if anyone knows what that is, but it's a minimum viable product design. Using your first use cases. Don't go nuts. Don't include projects you don't need. Trust me, you're not going to like that. It's going to be more nightmare than not. So you need to go back to your business objectives. Keep it simple. And cost is always a consideration. Treat it like your money. Right? We all like new fancy things. We all like the newest, fastest flash array with NVMe disks. We all like that stuff. But is it needed for your first cloud, your first iteration? Do you see it on the roadmap for a year? No. It's somebody's money. Someone's going to ask you these questions, right? And I don't know about you guys. I don't like to sweat in an office. I sweat enough as it is. I don't like to be like, why do we need 4,000 NVMe drives for web scale, for web servers? Yeah, it was cool. They told me that it was the coolest thing ever. Yeah, it is cool. Not at a cost of $26 million, right? So, as I said, treat it like your money. Architecture plan should be Should be fairly simple. And I don't really like to talk about this because it's so very personal to each cloud. But the architecture plan should be categories of hardware, right? What are you using for computes? I don't care who your vendor is, Dell, HP, Lenovo, Supermicro, you know, some sort of Chinese manufacturer that puts hidden chips in your servers. I don't know. I don't care. I don't care who you use. That's fine. But the point is it has to meet your objective, right? So if you need compute nodes to do heavy lifting, they're CPU intensive for most of your apps, then bulk up on that. If it's memory intensive, bulk up on that. You need to profile your apps that are going on there because stranded resources, I'm going to say this twice, stranded resources are lost money. Stranded resources are lost money. So if you have memory intensive apps and you're doing no oversubscription or barely any oversubscription, and you've filled up all the memory on a compute node, but you have 500 vCPUs left because this is a heavy compute node, compute node, that's stranded money. You can't use those anywhere. Same thing with storage. Same thing with network, right? We want to be smart about what we're doing. You have two different role categories for your hardware design, compute plane and control plane. Compute plane, we'll get into the definitions of those in a minute. And then your deployment plan with a list of these hardwares, a list of these components, should include everything needed by an OpenStack engineer to deploy the cloud. So you should be able to take this document, give it to a guy, tell him the root password is, and of course this is a guy you know, not just some guy off the street. The root password is, and Mr. OpenStack engineer, there's the terminal, here's the plan, have at it. And he shouldn't bother you unless he wants lunch or wants to be let out of the room, which after 8 hours they complain for some reason. So when I talked about the compute plane and the control plane, compute plane is based on your workloads. High availability is designed in by horizontal scaling and availability zones. Bigger isn't always better. Scale out, not up. AKA lots of small servers, not 5 really, really huge servers. You get a lot of resource waste and trapped resources with scale-up servers. Control plane, the requirements are driven by the services that will be installed, the projects you install. If you install every project under the sun, like everything, just like I'm putting everything in here. This is going to be the coolest cloud ever. Like even stuff that's in incubation, I'm just going to install everything. Well, all of that stuff is run by a database, and all of the queuing goes into RabbitMQ. So those two big services, they're going to need a lot of horsepower to run. And then you need HA, so you're going to have to buy lots of those servers. So if you're building a small cloud that has small requirements, should you use small servers? Right? Small enough to handle expansion over the time that you need till you build your next cloud or upgrade to the next release. So the control plane usually is typically no less than 3 servers. If you're doing it in the old monolithic way, nowadays they're using containers and they're spreading it across like 6 servers. All right? But in your dev cloud or your POC cloud, look at the load on those. Load shouldn't be very high. But when you're running your rally tests that you're going to do, right? Everyone's going to run rally tests and try to break your cloud. See how the control plane handles it. See at what type of load it handles it. If it dies too soon, obviously you need to add more meat to your control plane. But you won't know unless you test. High availability is handled by load balancing and clustering. If I had time, I was going to go through this, which is a sample architecture of NFV cloud. If you don't know what NFV is, it's just network function virtualization, but it has some requirements that are pretty specific. So we'll just move on here. This is what the infrastructure manager for an NFV cloud looks like. At the very bottom, you'll see it says NFV infrastructure, NFVI. That's where OpenStack lives, right here. Okay, virtual storage, virtualization layer, which is your hypervisor, and then compute storage networking. Same as any other cloud, and then you have a virtual infrastructure manager, which is OpenStack right here. Okay, all this other stuff up here is telco specific. But if you look here, they're going to be using Kubernetes on some servers, provisioning it by OpenStack Ironic. You have other servers. You have your runtime containers. But you see how they've put this together? APIs that are listed. They'll be using load balancer as a service, Magnum for Kubernetes cluster generation, Zun for Docker containers. But this is how a picture, this is, obviously you don't have to make yours look like this. But this is very clear and it's very easy to explain to other groups and engineers and executives, directors, whoever you report to, as to what you're going to be doing. These are just kind of outlining the projects that were cherry-picked to use for this architecture. You can see they didn't use them all. They could have used Kingling, right? They could have put Kingling in there. Anybody here know what Kingling is? Kingling. I learned how to say it right yesterday. I've been calling it Quingling for so many years. It's function as a service. It's like AWS Lambda. They don't need that. The VNF clouds, NFV clouds don't use that typically. So don't put it in there. You don't need it. And then some discussion is, thinking about the future, especially 5G and edge technologies. How does OpenStack fit? How does OpenStack fit in small installations? So we're not going bigger, we're going smaller. Maybe not all the services out on the edge to support VR, IR, self-driving cars, things that need low latency and high bandwidth. And they need to pass from node to node to node to node. And the workloads need to be instantiated on nodes. Maybe autonomous drones, the ones that follow you home and spy on you from our different governments. If you never see me again, now you'll know why. But these are some of the architectural things you need to think about, that you don't need to think about, but things that are going on. So if you're thinking about building these big clouds, remember, there are things going on. We're trying to make the clouds smaller and only use the very essential services that they need. Because some of these OpenStack clouds will be installed on poles. Yeah, on poles, with devices about this big, strapped to a tower, resilient to hundreds of degrees and freezing cold temperatures. Very cool. Maybe I'll have a talk next year on that. So, the final deployment plan. There you go. Some more things to think about in review. Planning to operate, logging, monitoring, alerting, governance, security, compliance, service assurance, and disaster recovery. Operators, we talked about operator education, system reliability engineers. Are you putting any DevOps principles in place? And configuration management. If you're not doing a distribution and following their configuration management tools, how are you going to do it yourself? Q&A. There's a microphone right here. Please use it. I'm deaf.
Yeah, so my question is just about...
I hear that.
You have just said on the configuration management.
Yes.
You didn't talk about any distro, if you recommend to go with any distro or do your own stuff with your thing.
Yeah, I did that on purpose. I did that once, and then I got a hit out on my life. So one distro was trying to kill me. No, but I'm kidding. They're all good. So all the distros are good, right? So you need to look at your mission and figure out what it is that a distro is going to do for you. A lot of it comes down to, do you like their configuration management tools? Do you like their installer? Do you like the way they upgrade? Do you like the way they handle containers and Kubernetes? Because a lot of the distros today are going in that way. So bare metal configurations, things like that. Any other questions? Go ahead.
When you do capacity planning,
yep.
When you do capacity planning, suppose if your capacity planning requires multiple data centers,
Okay.
how do you plan your networks? Do you plan multiple clouds, one massive cloud? What are the decisions?
The question was, when you do capacity planning for multiple data centers and you have multiple clouds, how do you do capacity planning? From what I've seen and what my experience is, they do multiple clouds. They may federate the clouds under one domain, so you can, when you're deploying from any cloud you can, any dashboard you can put it on any other cloud. But the capacity planning is basically physical infrastructure based. So whatever you have in those racks and pods that you're creating over and over again, you do the capacity planning there. And it's important to do, again, an elasticity coefficient based on what you're seeing, based on growth. Go ahead.
At what point do you decide to go with a multi-cloud versus a stretch cloud? Like, for example, let's say that the latency between the two physical localities is really good. Say you're only maybe like 10 miles away from each other. You've got less than 1 millisecond latency between them. Should you still look to deploy multiple clouds? Or is that considered core enough that your app can't tell whether it's in one locality or the other versus one rack versus another in the same data center? What are some of the thoughts?
You know, I used to say 10 milliseconds was about as far as I would go by putting remote compute nodes into other regions, into other data centers. You just use the construct of availability zones and host aggregates and regions to set up. If you can do that, if you can blow those out there without timeouts happening, and again, this goes back to testing, right? What kind of number of VMs are we putting out there in a row, right? And what kind of traffic are you seeing? Because 10 milliseconds can quickly become 100 milliseconds, and it could cause your cloud problems. And there's no real way out of it, because now you've got compute nodes over there. You'd have to put a whole new control plane over there, and then disconnect those compute nodes and connect them to the control plane over there if it goes bad. So you have to be a pretty compelling reason why you wouldn't want to have, you know, two different clouds. Especially with, there's a lot of management tools out there now that do cloud management. Cloud Forms by Red Hat is one of them, where you can put the APIs for different data centers in one tool, and then just click, I want it in this data center, go. I want it in this data center, go. It's one cloud management tool. So, and then you have two independent running clouds. Problem comes where you have independent images, you have independent users, and syncing, that type of thing. If you have a cloud management platform, it makes it easier to manage those things.